It's good.
Nice.
Are we recording?
Yeah.
I don't think so.
On jaw?
That's gonna
On
be
jaw.
recording.
Okay, here we go. Functions and graphs. Domain and range of f of x equals 2x plus 3.
You gotta hide it. It says auto hide. I cannot.
But it's select to max. So
Oh my god.
seriously.
Okay, so you guys know y equals 2x plus 3. This is what you've always learned. When x is 1, y is 5, correct? X is 2, y is 7, right?
You're right.
You can also write it as 1 comma 5, correct?
Yep.
And 2 comma 7, correct? Goodbye to this, because we are doing f of x equals 2x plus 3 in this class, right? So instead of making you can make an xy chart, but instead of an xy chart, it's an x and a f of xy chart. X is 1, f of x is 5. X is 2, f of x is 7. That's the difference. Your ordered pair is completely different. The way they do ordered pair is f of 1 equals 5. That's the same thing as 1 comma. I think some of you know this anyway. F of 2 equals 7. So make sure for the rest of this book, don't look at me and say, what's f of 2 equals 7? You know that it's really the ordered pair, 2 comma 7, right? F of 2 equals 7. So, okay, that's it. Domain is the x's, range is the y's. I don't think I needed to say that. But, okay, the vertical line test checks to see if it's a function or not. A parabola. If you do the vertical line test, it works because it only goes through the actual function only once. A vertical line test means you can't have repeating x values. You can't have repeating x values. If you check these points, this point is like 2 comma 1, this point is 4 comma 4, this point is negative 2 comma. You can have repeating y values, you can't have repeating x values. Like this point right here, let's just pretend it's 2 comma 1. Over here, right across from it, is a negative 2 comma 1. It's okay to have the same y values. You can't have the same x values. A sideways parabola. A sideways parabola is not a function. This is a function. This is not a function. And you can tell if you plotted this point here and plotted this point and I asked you what the points were, the x values would be exactly the same, right?
Right.
Whatever they were. So, okay, is that it for that page? Nope, we have a whole bunch of interval notation on this page too. Before we do interval notation, just tell you what the horizontal line test is, because we did that one too back in college algebra. Horizontal line test checks if the inverse is a function or not. It checks to see if the inverse is a function or not. So this is a great example. You remember how to find the inverse? You interchange the x's and the y's. You guys remember how to find the inverse of a function, right? Interchange the x's. I don't think we do that right now, but this is a good one. The horizontal line test, if I did this, believe it or not, this function and this function are actually inverses of each other, which is perfect that I put both of them in there. When I do the horizontal line test to this, how many times does it go through it? Twice. It means that the inverse is not a function. Isn't this the inverse of that function? And it's not a function, is it? So without even drawing the inverse, I can check to see if its inverse is a function or not without even drawing it. So anyway, that's the horizontal line test. Interval notation. You guys know interval notation. I'm just going to go through it really fast. This is a B. I guess it's not. Let's not use B. Let's use numbers. 3, open circle, and all of this shaded to the right. Let's make this a 3, and let's make this a 0. Closed circle at 0, open circle at 3, and everything in between there is shaded in. And we'll do one more. We'll do 0 here, shaded to the left. We'll just do a 2 here, open circle shaded to the right. And we'll just quickly review interval notation. So we'll just quickly do interval notation. A parenthesis, because it's an open circle, you're going to start with 3, and you're going to infinity, and there's a parenthesis at the end. 3 to infinity. The next one, you start at 0, and there's a bracket because it's closed, and you're going to only 3, which is a parenthesis. And then the last one, a negative infinity first. You're starting at a negative infinity and you're going to 0. And is that closed? It's closed. So you're going to put a bracket, union with, there's another section that you have to do, and it's a parenthesis because it's an open to, and you're going to infinity. So that's just quickly how to do interval notation, which all of this is review anyway. This whole chapter is review. We're done with that part. The next part is all the parent graphs. We're just going to quickly run through the parent graphs, which you should know. Y equals X. Maybe while you're waiting, you can maybe put all the graphs on here. I could have done that for you, but I didn't. I mean, your graphing calculator will tell you what they all look like too. But you should be able to recognize all of these parent graphs. And I think there's even more, right? There's 2 more, might as well put them on here. You can attain all of these by using your Y equals button on your graphing calculator too. So you would just put y1 equals x, and you would see what it looks like. Y equals x squared, see what it looks like. Y equals x to the third, see what it looks like. But I think most of you know what these all are. This is a line, a positive slope going through 0, 0. Y equals x. Y equals x squared is a parabola going through 0, 0. Y equals x to the third is I call it a snake. Starts down here in the third quadrant, goes up into the first quadrant. Y equals the square root of x is a swoosh, I called it. And it's a positive, so it looks like this. If you don't believe me, you could sit there and plot points, or you could use your graphing calculator, and they all look like this. The cube root of x is the inverse of x cubed. It starts down here and goes back up. Sideways snake. The 1 over x is a hyperbola. It's in the first quadrant and in the third quadrant. 1 over x. I know this absolute value sign kind of got butchered, but it's the absolute value of x, which makes a b. And maybe you don't know what x to the 3/2 looks like, but you kind of have to recognize that it makes, this is what it makes. I know you haven't seen probably 6 and 8, but you can always use your graphing calculator if you're not recognizing the parent graphs anyway. So basically these are called parent graphs, and for example, you could have a y, you could have an equals, you could have the square root of x minus 1, and then you could have a plus 2 out here. You're staring at this one and going, wait a second, that looks like the square root graph. I know what the parent graph looks like without using my graphing calculator, because half of your AP test is without a calculator and half of it is with a calculator. So you need to recognize this and say, wait a second, that's a square root graph. All I'm going to do is move it from 0, 0 to the right one and up 2, to the right one and up 2, and let's just pretend it's about right there, right? So you need to know how to depend on your calculator and not depend on your calculator throughout the year, because half your AP test is with the calculator, half of it is without it, so. And let's say this is the no calculator section on the AP test. How many of you are gonna say, forget this, I'm just gonna skip this problem. I have no idea what x to the 3/2 looks like without a calculator. You can always resort back to your most basic Algebra 1 class and do what? Plot what?
Point.
Plot points. You can always plot points to find out what the graph looks like. X is 4. X is 4. What's 4 raised to the 3/2 power? I'm gonna go over here and say 4 raised to the 3/2 power, right?
6.
I don't think so. You have to change 4 to what? 2 to the what power?
Second.
Second. And you still gotta raise that to the what power? 3/2. What happens to the 2 2's?
Cancel.
Cancel out. What's 2 to the 3rd power?
8.
8. When x is 4, what are you gonna get for your y value on here? Is an 8. You have to know how to change things to base numbers, right? And why did I pick 4? Why did I pick 4? Because that is a 2 to the what power? Second, and I know that this 2 and then this 2 cancel each other out, right?
Right.
So, and I probably wouldn't have picked, I don't know, next one I probably would pick is 9 next, right? Because I know that that can be changed to 3 squared. So just because you don't know what this looks like, you can always plot points to figure out what a graph looks like anytime in math, right? So it might not be perfect, but okay, moving on. Finding the domain and the range of y equals x squared minus 9 and the 4th root of a negative x. So I think I'm gonna do the first one, no calculator, and I'm gonna use the second one, calculator, just to change it up. So while you guys are waiting for me to grab my calculator, I'm gonna do the first one not using a calculator, and the second one I'm gonna use a calculator just to change it up and say that you don't always have to use the calculator. So for the first one, let's say the first one is not a non-calculator section on the AP test, and it'll say find the domain and the range of this problem, and you're gonna say that's right, I know what x squared looks like, it looks like a parabola, right? And I know that the negative 9 is on the outside, so it's gonna move it down 9, right? So we're gonna move it, I'm just gonna put that, whatever, there's 9, and it's gonna still face up. And now that I have my picture, which only took a second to draw, I can state my domain and my range. And I'm just gonna put a D down for domain. Domain is the x-axis, and how wide is this really getting? Yeah, a negative infinity to a positive infinity. And the range, it's always the lowest to the highest, and the lowest spot that this is gonna go to is a negative 9, including a negative 9 to infinity. So there's one not using a calculator, you shouldn't have to. The next one, I'm gonna use a calculator, so I'm gonna do what, the 4th root of a negative x? Well, the first thing I need to do is I wanna see how to graph it, so I need to hit my y equals button on my calculator, right? That does all the graphing is y equals. But somehow I need to figure out where the 4th root is. But you don't need to use the 4th root because you also learn this. You learn that a negative x is raised to a power, and what's the little imaginary number right there?
1.
A 1, and that's a 4. So if you don't want to use your radical button, could you use your caret button and go I'm going to use my caret, I'm going to do a negative x in my parenthesis, and I'm going to raise it. A negative x, and I'm going to use the raise button, the little caret button, and use 1/4 and 1/4. And it does, do you have a negative x in parentheses raised to the 1/4? If you don't like 1/4, you could use 0.25. Isn't that the same thing as 1/4? Or you can go under math, and I'll show you where the 4th root button is. Under math, I can show you the 4th root, but I'm going to graph it now. And you know what? It looks like a snake, but we've never done it this way. The snake it always went this way. The snake is going this way in this problem. Is that what your snake looks like? Is it going to the left? not snake,
Swoosh.
swoosh, I'm sorry, yes, swoosh. So the domain is, how wide is this gonna go from a negative infinity to 0, bracket, and the range, how low is this? 0 to, oh, bracket, sorry, bracket, 0 to infinity.
We got a bracket on the range, or is that a bracket?
Yeah, I think
That's a
you switched
bracket.
it.
I switched it. Yep. If you don't like raised to the 1/4, if you look under math, the 5th one can do the x root of anything. Under math, the 5th one will give you the 4th root and the 5th root and the 6th root. It does cube roots, but it doesn't have the 4th root. So then you might have to reset your calculator if you did the graph. I don't know. Okay, moving on. Let's see. Oh yeah, part 5. Odd function, even function. You guys remember this from college algebra last year. I think this was chapter 3 in college algebra. What is an odd function and what is an even function? What you do is you test 2 points, 2 and -2. You test 2 points that are opposites of each other. You can do 2's. You can do 1 and -1. You can do 2 and -2. You can do 3 and -3. You get the point? You're testing your x values and they have to be opposite. If these numbers end up becoming opposite of each other, then it's a what function? It's an odd function. And you guys remember doing this last year. An even function, you're doing the same thing. You're still using your x values as being opposites of each other. But if your y values end up being identical, then it's a what type of a function? An even function. And then there was another one called a neither function. Do you guys remember the neither function? Let's test that. I'm gonna go out on the limb and use 1. And what's the other point we have to use then? -1. Okay, let's just pretend I'm trying 1 and -1. And my one answer for my y is 3. And my other answer is 7. Wow, how'd you know I was gonna say 7?
Because I wanted 7.
I wanted 7 too, and we both were thinking 7. Wow, that's crazy that we both, because I was writing it when you said it, I'm thinking, wow, she just said 7. Anyway, it's not opposite, they're not the same, they're not even close to being, it's a neither function. So, I'm gonna show you this, and here we go. Y equals x to the 3rd minus x plus 4, and let's check to see if it's an odd or an even function. So, let's check it. What did I do? Let's see. Let's do 1 and -1. 1 and -1. 1 take away 1. What's 1 take away 1? 0 plus 4. You get 4 for that. You put a -1 in there. What's a -1 times a -1 times a -1? -1. And a -1 plus 1 is
0.
0 plus 4. So it looks like it's
Even.
it looks like it's an even function, okay? But this AP Calc class tries to trick you, so I'm going to show you something instead. So everybody go under Y1. Everybody goes under Y1 again. I remember this from last year. I gotta remember all my notes from it. Clear it, and I want you to put x cubed in there. X cubed. What is it next? Minus x plus 4. Okay, so x cubed. I don't care what the graph looks like. Just put in x cubed minus x plus 4. Above the graph, though, there's a table. Do you see that the word table shows up in blue? So hit second table. And now arrow up and just start staring at the points on there. And I love this table because what did we just do? Did we just show all of our work to come up with our answers?
You press, it's on the calculator. Second.
Table.
So do you graph first?
Yeah.
No, you don't need to hit graph. No, it's second table.
Where's
Do you see all the work we just did to come up with those answers?
Where's the second?
But-
Oh, second table.
Second table.
Hit it.
Arrow up, please, so that your table shows a -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Is that what you have showing? Please show that.
Oh,
Yeah.
Show me a -4, -3, -2, -1. Can you show me those on your table?
Yeah.
Okay, are you looking now?
No.
So we just did 1 and -1. Did we just do 1 and -1?
Yeah.
What are the answers for the y values? Did we get 4 when we did it the long way? Okay, it looks like it's an even function, doesn't it? We only tested really 1 point though. We only did the 1 and the -1. Let's look at the 2 and the -2. What's the 2 and the -2?
-2.
And 10. It looked like an even function, but that was the only one that worked perfectly at 4. Now let's look at the 3 and the -3. Is it for sure an either function, like looking at the 3 and the -3? Look at the 4 and the -4. Do you see that if you don't test more than 1 point, it might be an even function, but it's really a neither function, isn't it? This is definitely a neither function. It just shows you that sometimes, if you don't look at it careful, that you might think it's the wrong function, and this is definitely, looks like an even function, it's definitely a neither function. And you see the shortcuts you can use by using your calculator, right? You ready to do the next one? Let's see if y equals x to the 2/3 is an even, a neither, or a odd. Not working.
Isn't it I before you?
What did you use? X cubed minus x plus 4, second table. Second plus reset. You already did this? Go under y equals, plug in again, x cubed minus x plus 4, which you just had in there, but now I'm gonna hit second table and it's showing up. Reset your calculator. I have a feeling you're resetting it, but you're not moving it down to actually say to reset. Do you know what I'm talking about? When it says to reset, you have to actually say, I wanna reset the calculator.
I do second,
Plus,
7, reset.
and then go all rounds, enter. Now you have to tell it to reset. Now it's reset. You're not telling it to reset. Okay,
So you've never reset
Just
your
7.
he's never reset his calculator then, because he never told it to
Okay, I
reset.
reset.
Okay, but did you guys already do this one already? X raised to the 2/3 power? Okay, second table. Okay, I'm looking at the, ooh, this is a good one. I like this one. I look at the 1 and the -1, everybody's staring at the table, and I see that the y values are exactly the same, correct? Then I look at the 2 and the -2 and they're exactly the same, correct? Then I look at the 3 and the -3 and they're exactly the same. I'm not finding anything wrong. It's definitely a even function. Yeah. Okay, moving on. Good? So everybody knows how to find an odd, even, and neither. I didn't give you an odd one, but you get how to get an odd one, right?
I'm gonna know that in my notes.
Okay, next one. I think that's it for that page, right? Okay.
Yeah.
Oh, piecewise functions.
Yeah.
Let's see now. I taught you guys how to do this 2 days ago. How to do piecewise functions.
Stat edit.
Nope. Nope.
Plug them all in.
Yeah, plug them all in. Plug them all in. Under Y1, what do you plug in first if somebody wasn't here? You use what first?
Parentheses.
Parentheses.
Negative X.
And then -x. And then parentheses. And then, nope. Then you use
Math button.
parentheses.
Yeah, where are we at?
And we're plugging this into your calculator. Parentheses, -x, parentheses, parentheses, x. Where do you find the less than button?
Second.
Second math. Under what? Less than only?
5.
Less than 0, parentheses. So 1 is done. Second one. Parentheses, x squared, parentheses, parentheses, x. Boy, this takes a while, but it sure beats. X is greater than or equal to 0? X is greater than or equal to 0, parentheses, and then parentheses again. X is
X is
What
less
do
than
I
or
start? How do I start?
less than
Oh,
1.
otherwise.
No, but like.
I'm sorry.
parentheses.
You can't put that all together. It's dumb.
Can you just?
You
do
cannot put this all together in parentheses. It
doesn't
won't let
matter
you
if
do
you
it.
do 0 is less than or equal to x, and then you do
X is
is
greater
less
than or equal to
than-
zero.
doesn't
matter the order.
It doesn't
Yes,
matter the
it doesn't,
order.
it doesn't matter the order. No,
I
it
did that
doesn't.
one last time.
Second math. And then parentheses, 1, parentheses, I'm sick of saying that, but X is greater than or equal to, I'm already at the last one,
Wait,
greater than or equal to
No,
1.
we're just doing the left side.
You just doing the left side?
Well, I did it way wrong.
I don't know, my God.
Do I do,
What'd you do?
the right side too?
Yeah, so it's
Ah.
the
This
line,
shows-
then there's a little mini curve, and then
Yep,
it's straight
there's a
across.
line, a mini curve, and then
But
another
that's not three
horizontal
different
line.
graphs.
This shows this is not right.
Yeah, it is.
Yeah,
That's what I
it is,
had.
yours is blowing up, that's
Yes.
exactly what I have.
And then
Whoop.
in between, so there's a
Nope, you
line
did, you
on
wrote
both
something
sides,
in wrong.
and then that little space is a parabola. It's a little mini curve.
0.
You cannot put that.
But you
in
just
there.
graph it as
It
a
has to be separate.
Yeah.
The
Oh,
so
really?
I mean,
Like
$120
I-
calculator, you think you could do that.
I know.
Do what?
Whoever makes
He
these.
he tried to put the middle part together as one, and
It's whack.
that was split it.
I think you gotta go zero.
You have to do
Oh,
it
no,
separate.
And X
It's
is
so
greater
dumb,
than-
you should be able to do it the way you just did it, and that's why you have an error in yours. It's just the way it is, you gotta follow, you think you should be able to do this middle part as one, right? But you can't, you can't, you're not gonna get the right answer if you try to put that all together. It's just, it's really weird, $120 calculator, you think you could put that all together, and you can't. You gotta separate it into two different inequalities. It, like, Ava said, it looks like a straight line, and then there's a curve, a curve like this, sorry, and then it goes like that.
So do you remember when we, or, the
It-
open
Oh,
circle, closed
that's kinda
circle type
nasty.
of
Mine
deal?
kinda
You can't tell it on
Can't
here.
tell,
Read.
is that important?
Here, I'll help you.
It will, yes.
Oh, I
So,
got it.
so basically at
No,
zero,
read it.
it's open and then it's closed, so, but it's really closed then, cause they
come together.
interlocked with each other, and this is also, everything's closed because this is open and this is closed at the one spot, they cover each other up.
Okay.
So there is no open circles, it's, everything is closed. And if you really wanna do this one, you can, you really don't have to do this one, you guys know how to do it, right, piecewise functions?
What do you call this shape?
For the second one?
Pieces,
First one.
pieces of functions,
Like
see?
that.
What do you call that
Let me see
shape?
yours, let me see yours.
Piece of a function, very good, yeah.
Yeah.
You
You
probably
go to
typed in
zoom,
the
you
first
go
one.
zoom
Did
out.
you do the negative x? In the first
Hey, we're all learning.
And what do you call this shape,
back
you
to the
guys?
Right.
Piece of functions.
You didn't do the
Pieces
negative
of a
x.
little-
I'm
before
gonna call
the
it
x
squeeze.
left.
This
Pieces
one.
of
Why
everything.
would you type that in?
Because that's part of it. The little number, or the little part before, that's
You only
part
got-
too.
Hey, Miss Shosh.
I thought
She
this was
forgot
the
the
left
left part.
side.
Oh, she missed the whole
Is that your
function
neck?
part, the negative.
Shosh.
Yeah.
This is the domain.
I don't know what.
This is the function that makes this line only to zero. That's the domain.
This shows do the graph and next one.
Okay,
Comes
I'll
out
grab
with-
that. This only goes, this
You
is
have to
the
type it
domain. This is the domain, this is the actual function that it's making. This is the function line, this is a function parabola, and this is a function horizontal line.
So Tori, when you
These are
write-
actual
Morgan,
functions.
no,
I'm
that's
not gonna
right.
retype it in,
You
but
don't-
when
all
you
need
do
is
the
the
second
second
one,
Yeah,
no,
we
you
have
also
the
take
same
one.
meaning.
Like you said,
Oh.
that's in front, you also.
You put, so you put the thing in front of it?
That's the function.
But make sure you put that in like, just so you don't.
You wanna see what that looks like? It looks
Well,
like,
here's this one.
well, maybe somebody should just come up and draw
This is
this.
what it looks like, but what are you supposed to do? You're
There's
supposed
two
to
blue
use both
lines. What do you?
Isn't the graph right, the piecewise function?
So that's all
I
you
have
do
it.
is
Do you
go
wanna
for
just
it.
look it over?
Yeah, that's what I wrote. Like,
Yeah,
just like that.
I'm at the end of it, so let's see.
Like what?
Parentheses. I'm almost done, I'm at the end of putting my parentheses, parentheses.
She should probably do this.
X is greater than or equal to?
We got
Okay,
time.
I'm there, I'm
We
there.
got time. How can this thing not tell the time?
Instead of like a lot of.
Yeah,
I
it's,
can't believe the new ones don't have.
What do you
Only
do?
do the red one, right?
Do you do the blue and the red?
Oh, yeah, this is
oh, yeah, you, didn't you see the blues and the reds
But
go?
what's the point of the left?
How often do you have to try this?
I see.
This
red.
one only goes to zero, so this is the right answer to the problem. This one goes on the axis, you don't use it.
I tried.
And then the other. Okay.
And the other one looks like this, so that's the answer to that one. Didn't you see these lines, didn't you see the colorful lines?
But I didn't understand the.
Now you know
Yeah,
why.
now I know why.
Because now this
It's
line
good.
only goes to zero, so this plateaus out, cause it doesn't matter.
I was just
And then
interested.
it's one. Like
Yeah.
every answer is one, so it's.
That's why you saw those other colors hang out on that zero
Because
too.
it's y equals one, just like any other.
Yeah.
I get it now.
Yeah.
Wait, so isn't this just the answer? Cause mine doesn't have the colors.
Yeah, you don't have, that's good, 'cause then you don't, that extra blue is mixing them up and you're better.
But this is all the answers.
Yeah, that's the answer.
Was I supposed to start the arrow?
Yeah, keep going on, keep forever.
How often are we supposed to charge these?
Oh,
I
good
don't
question.
know.
I was
That's a
also-
good
I only
question.
charge it
How do you
like
check the
twice.
battery?
When you charge those.
I
You
know
know.
here.
Oh, yours.
Yeah,
Oh,
how
they're not
So I just usually
batteries.
work around
Are-
the.
I think
I
second
charge mine
memory,
twice.
I don't know, it tells you when you're low.
But
No, no, no,
On
no,
that.
no,
It'll
no,
tell
no,
you,
but I don't
it'll
use
tell
that.
you to
I'm
change
not
your batteries, and you can go almost a month or keep telling you to change your battery. Another month, change your battery. I can go almost a half a year saying, okay, I'll change my batteries.
No,
It signals like after 2 months after you change your battery.
Yours, you don't have
And
to.
a week after
No,
this
this
is
is hers.
Okay, yeah.
Until the silver.
Okay, let's keep going. Moving on, are we on the last page?
Yeah.
Okay, this is the last page already?
part 7.
So you write down every line. that
Oh,
shows
yeah,
up.
two more.
You write down every line
No
that shows up on
way.
your calculator?
No, just the part that's, not the blue, not this blue one, because the blue one has to be X is less than zero.
Okay, so then why does it show up?
I'm not liking all these parts.
On the colored one, it does show up.
Yeah,
Yeah, and if you would have looked on these, all of these would have showed up on the one too, you probably didn't even notice it, 'cause they did show up,
Okay.
so. Okay, the next part, oh, we have two more parts, part 7 and part 8. Part 7, you're given the graph, you have to write the piecewise function, you did this back in algebra
I'm sorry,
2.
there's
no
not
graph
a
there.
graph.
I know, I'm putting it on there, I'm gonna put it on there, let's see. You're gonna put a closed circle at 2, and you're gonna put an open circle here, and you're gonna connect those two dots.
Where's
Where's here?
0, 2, and 2, 0.
Thanks for
0, 2,
Oh, open circle?
0, 2, and 2, 0. And then you're gonna put another one at 2, 1. You're gonna put an open
Graph, can you make
circle.
them not so close? They're real.
Well, that's
small.
2, 1 right there.
Yeah,
I
but
know.
like,
2, 1.
it's small.
And then 1, 2, 3, 4, 5 closed here.
1, 2, 3, 4.
This is not
You're gonna have a point at 2, 0, an open circle at 0, 2. You're gonna have an open circle at 2, 1, and a closed circle at 5, 0.
So 4 points.
4 points. Yeah.
Nice. Awesome. That's nice.
I guess I could have made that bigger, but I didn't.
Good.
So, piecewise function, f of x equals, and you know you only have 2 of them to do, right? Because we only have 2 functions.
Right.
And they're both lines, aren't they? So we have to use y equals mx plus c.
Sure.
What's the b in this problem? 2. And what's the something x? It's x plus 2. Yeah, it's a 1x, right? Down 1 over 1, down negative.
Negative x,
You're
yeah.
right. Negative x plus 2, it has a negative slope. Negative x plus 2 is that function, right? From
Down one.
x is less than or equal to 2, right? Isn't the x function starting at 2 and going to where? This line only goes from what x function to what x function? 0 to 2. Yeah.
What? I got none of that. Can you redo that?
This line goes from 0 to 2.
Uh-huh.
That's the length of it.
Okay.
That's the domain, 0 to 2.
It stays between it.
This is how math goes.
And this is this has a line underneath it because it's a closed circle. This one doesn't have a line underneath it because it's an open circle, right? And now we have to do the same thing.
Wait, one question, one more question. So it's only facing the 2, like it's x is less than 2.
This line is from 2 to 0 only.
Uh-huh.
That's your domain.
And it's less than or equal to because it's closed?
Yeah.
The first part is.
Okay.
Yeah.
That's the
Let's just do the domain for this one. X is what? X is
5.
less than or equal to 5, but greater than what? 2. And it was supposed to be an open circle, but I accidentally covered it up when I did it. There's the domain. Okay, what's the slope of this guy? It's negative, isn't it?
Negative
1/3.
1/4.
Okay, negative 1, 2, negative 1/3. Down 1 over 3. Down 1 and over 3. Rise over run. So it's a negative 1/3 of an x, right? Plus negative 1/3 of an x plus, and you have to figure out where it crosses the y-axis, right?
Right.
Well,
Why didn't you do?
can't you, what?
Didn't you do like y2 minus y1 to figure out what?
Yeah, that's what I was gonna do.
Oh, sorry.
You could do y2 minus y1 to figure out the slope, which was a negative 1/3. I counted, I went down 1 and over 3.
Yeah, but then to figure out what the intercept is.
Yes, I would do,
Weird.
I would go y minus something equals a negative 1/3 x minus something, right? And then what's one point that's on there?
0, 5, 5, 0.
5, 0, so x is 5 and y is 0. And you get y equals a negative 1/3 x, are we right on the negative 1/3 x?
Yeah.
Plus
5.
5/3. 5/3.
3.
What? Love it. Yeah.
Oh, part A.
Tomorrow.
Okay, yeah, that's fine.
Wait,
Well, I got a minute, I could finish it.
Yeah, finish it.
Finish it. I got a minute. Composite functions really fast. This won't take long, this will take a second here. Composite function, f of x is x plus 2, g of x is x squared minus 2, and they want you to find f of g of x and g of f of x, right? You've done these before. G of x is what? It's this, and all of this has to go inside of the f function, right? So all of that has to go in there, right? And you're done. X squared minus x plus 2, final answer. And then we're gonna go the opposite. We got 30 seconds to go the opposite way. F of x is on the inside, which is this, and where does all of that have to go? All of that has to go into g of x, so all of that has to go in there, and all of that has to go in. This is a harder one, because it's x plus 2 raised to the what? Squared minus x plus 2, and then I want you to simplify that
Okay.
by foiling it and taking the opposite and simplifying it, but that's about it. So, let's just see if this recorded now.
I have a hunch it's no.
I
Why? Negative.
Earlier there was a little recording